SolidWorks Simulation, Lecture 10, Parametric Analysis. And first of all, we load the software, SolidWorks Simulation, and then load the toolbar. And this is the toolbar. Open the static analysis. And for the material, I'll choose 1020 mild steel. Mesh. Hide the mesh. Constraint. Loading area. Direction of the load. Magnitude of the load. Solve. And the result will be displayed in MPa unit with a numerical value of floating format with 4 digits under decimal. And also, this is easier to read. For displacement, I'll also change the unit to be millimeter, and the numerical value format will be floating point with 4 digits under decimal, so it is easier to read. Now I'll open another case. It will be design study. Now first of all, deselect optimization, because this is not an optimization study. It is a parametric study. So now I'll announce 3 parameters. First one will be W. It will be width of the beam. So the parameter will be connected to this dimension. So this dimension will be connected to the name of parameter W. So I'll announce a second parameter H, which is the height of the beam, and I'll connect this parameter with this dimension, so the dimension is connected to H parameter. Now I'm not going to define a parameter for the length, because I'll fix the length of the beam. Now I'll define another parameter to be MTL, material parameter, and the category will be changed into material. So I have announced 3 parameters, and for each parameter I will define the range from 50 to 60 with a step of 5. So for the width of the beam, it will be 50, 55, and 60, 3 levels. And for parameter H, we also define 3 levels, 50 to 60 with a step of 5. So it is also 50, 55, and 60 with 3 levels. And for the material, we'll select 3 materials: low carbon steel, and stainless steel, alloy steel. So now I have 3 materials for MTL, 3 levels: low carbon steel, stainless steel, and alloy steel. So for each of these 3 parameters, each have 3 levels. So they are totally 3 times 3 times 3. It will be 27 scenarios or 27 cases. Before I run the procedure, I need to define constraint on the procedure. So first of all, I will add the scenario constraint. The type of constraint will be simulation data, the stress, von Mises stress, with a unit of MPa, and the model max across all steps. I'll define it, and the stress will be lower than, less than, look here, the original one is 4.7 MPa, so the cross-sectional area increased from 50 to 60, so the stress will be lower. So I'll define the first constraint to be lower than 4.7 MPa. And another constraint sensor will also be simulation data, the displacement data on resultant displacement. The unit will be millimeter, and the model maximum will be less than, look at here, the original displacement is 0.319, so I'll make it 0.315. as the constraint for the procedure, and I'll run the procedure, and the software will calculate all the 27 scenarios for me, or 27 cases, and I'll stop recording here. The procedure has calculated all the 27 scenarios or cases for me, and including the first original scenario, there are 28 scenarios or cases, and it is almost done. And these are the result of all the 27 cases. You can see here that the width of the beam range from 50 to 55 to 60, and also the height of the beam 50, 55, and 60. And there are three materials: 304 stainless steel, and plain carbon steel, and alloy steel. So all the parameters have three levels, and these are the result for all the 27 scenarios or cases. And the result is here: the stress in MPa unit and the displacement in MPa unit. And if the condition meets the constraint requirement, the result will display in white background. And if the constraints are violated, the color will be red. So it is easy to read. For example, in this case, the constraint is violated because it is lower than it is higher than 0.32, right? So this condition is violated. And in this case, both conditions are violated. So you can easily read from here that these two cases are the case where the conditions, the constraints are violated. And these are the condition where the constraints are followed. So the software runs all the 27 cases at the same time. So this is the parametric analysis of SolidWorks simulation.